The universe began with a bang. The Big Bang caused the exponential expansion of the universe. The universe has been expanding ever since. But what caused the Big Bang? How can something come from nothing? We're going on a journey to the beginning of time. To try and answer one of the most intriguing questions of our origins, what happened before the Big Bang? Our universe is a massive structure that our brains struggle to comprehend. But how did it all start? The Big Bang Theory no longer describes the universe's origin. So if the Big Bang was not the true beginning, what was? What happened before the Big Bang? Let's take a look at what science says. For more over 50 years, we have received clear scientific evidence that our universe as we know it began with a hot, dense Big Bang. Or at least, we assume that was the narrative. The universe began a finite length of time ago with the Big Bang. Today we know a lot more than we did back then, and the picture isn't quite clear. Let us go back to the beginning of space-time to better grasp this. Our universe began 13.8 billion years ago, in a volume of space smaller than a tennis ball. All the matter and energy we observe today was concentrated in that small volume. Despite all of this energy in a compact place, the cosmos did not collapse into a black hole. Instead, it began to expand tremendously, and it has continued to do so. Vesto Slipher originally observed the expansion of the universe in the early 1920s, and in 1929, Edwin Hubble, who had access to some of the world's greatest telescopes, proposed the Hubble law. In later years, scientists were able to improve on Hubble's work by observing distant galaxies and supernovae, and the results were shocking. The cosmos was not just growing, it was expanding at an increasing rate. Regardless of how lovely the universe is, there are certain observable phenomena that require explanation. Some of phenomena include the receding of distant galaxies in proportion to their distance from us, initially noticed by Hubble himself. The universe at vast distances appears to be less clumpy and more uniform. The existence of an extremely cold, but clearly visible background of blackbody radiation in all directions in space. One paradigm that is consistent with all of these data is the Big Bang. According to the Big Bang Theory, our universe began 13.8 billion years ago with the explosive explosion of a very small primordial nugget. Over millions and millions of years, the universe cooled, resulting in the development of stars, galaxies, and planets. The universe continues to expand as a result of that explosion. This indicates that the cosmos was hotter and denser in the past. And when we try to extrapolate far back into the history of our universe, things get interesting. In many ways, the Big Bang's basic notion was that if you have a universe filled with matter and radiation that is growing today, if you travel far enough back in time, you would arrive at a state that is so hot and dense that the rules of physics break down. Everything we see in the universe today spans 46 billion light-years in all directions, and it all began in a hot, dense, and fast-expanding condition. Many people, including yourself, may be tempted to trace it back to a small, solitary hot, dense state known as a singularity. But resist the desire, as it is completely wrong. The Big Bang was not the beginning. That credit is due to inflation, and everyone should understand why. Inflation is our best scientific theory for what happened before the Big Bang. In 1979, a young scientist named Alan Guth established the concept of the multiverse. He and his friend Henry Ty sought to discover how the particles might have arisen in the early universe. Alan discovered something unique about their equation, which describes how new particles were generated in the early universe. In his equations, he discovered evidence that gravity might be repulsive in the harsh environment of the early universe. The conventional understanding of gravity among humans on Earth is that gravity is attracting in nature. However, the equations of the early cosmos indicated a distinct feature of it. This repulsive gravity would tear apart and repel everything around it, resulting in a catastrophic expansion. This force was so powerful that it could take a molecule and blow it up to the size of a galaxy in less than the blink of an eye. This remarkable revelation gave rise to the hypothesis of inflation. Instead of projecting the Big Bang all the way back to a singularity, inflation implies that there is a limit. You can only return to a given high temperature and density. According to the grand notion of cosmic inflation, this hot, dense, and uniform condition was preceded by a state where the universe did not contain matter and radiation, but rather a large amount of energy intrinsic to the fabric of space itself, which caused the universe to expand exponentially and at a constant, unchanging rate, causing the universe to be flat, empty, and uniform, up to the scale of quantum fluctuations, and then inflation ended, and here is where the hot Big Bang originated. The strong gravity of inflation triggered the Big Bang. This repelling gravity drove the universe to expand outward. Cosmic inflation not only explained the mysteries that the Big Bang theory could not explain, but it also made several new predictions that have since been confirmed. There is still much we don't know about cosmic inflation, but research from the last 3 decades strongly supports the existence of an inflationary state that preceded and set up the hot Big Bang. Taken together, this provides enough information to determine what the Big Bang is and is not. It is the belief that in the distant past, our universe was hotter, denser, and more uniform. It is not the idea that things can grow arbitrarily hot and dense to the point that the laws of physics no longer apply. It is the belief that as the universe expanded, cooled, and gravitated, we annihilated our excess antimatter, resulting in protons, neutrons, light nuclei, atoms, and eventually stars, galaxies, and the universe we know today. It is no longer assumed that space and time originated from a singularity 13.8 billion years ago, and it is a combination of conditions that existed very early on but were preceded by a different set of conditions, inflation. The Big Bang may not have been the absolute beginning of the universe, but it was the beginning of our universe as we know it. It is not the start, but rather our start. It may not be the complete story in and of itself, but it is an integral part of the broader cosmic story that connects us all. A final issue that may cross your mind is, what comes before this inflationary state? We just have theoretical possibilities with little facts or information from that period in our universe to guide us. It could have been eternal in the past, a true singularity before it, or something else. As far as our current observations go, we haven't even considered a way we could possibly know. At such extremes in time, our physical laws shatter. And speaking of time, time was established after the Big Bang. It may be an emergent property of our universe, or it may have always existed. However, with our current grasp of physical laws, we cannot learn more about the period prior to inflation. We'll continue to hunt for clues concerning the nature of inflation and what caused it. Keep all options open as possibilities if you like, but remember that supposition is no substitute for the best that science has to offer right now. But one thing is certain. Inflation occurred prior to the Big Bang, and anyone who says otherwise is more than 3 decades out of date.